Welcome, class. I just want to say congratulations. We are technically halfway done geometry. We just finished chapter 6. Today we're going to start chapter 7, and all we have to go to is chapter 12. So it's flying by. The first section in chapter 1 is probably a section you're familiar with. You've probably seen it at some point in your mathematical career. First thing we've got to talk about is our good old friend, the right triangle. And in the right triangle, we have to remember the parts of the right triangle. So if you recall, most people should be able to remember what the longest side is across from the 90 degrees. That is the hypotenuse. And one thing you've got to remember is that the hypotenuse is always the longest side of the triangle. It is always across from the right angle. So you do have to remember that. Can't forget it. If it's not the hypotenuse, we have to have the name for the other pieces. And the other pieces are called the legs, or leg and leg. The legs make up the right angle, so that's how we know those are always going to be our legs. What chapter 7, section 1 is Pythagorean theorem. And if there's one thing I can tell you, you are not going to leave geometry forgetting what Pythagorean theorem is. So Pythagorean theorem is definitely going to stick with you for the rest of your mathematical career. And what Pythagorean theorem shows us is that if you kind of look at this, it's a little better sketch. It just kind of shows you that the area of this, let's call this, okay, so there's a right triangle here. And the sides of the right triangle are A, B, and C. And so what Pythagorean theorem states is that the area A squared plus the area behind B, which would be B squared, always has to equal C squared. So if you see here, 11 and 17 is going to give us 28. No matter how I move this right triangle, I make it bigger or I make it smaller, this area and this area are always going to equal the green area in any right triangle. So that's what Pythagorean theorem states. So if we come back to this video and you look at this right triangle and you ask yourself, what is the length of this leg? This leg is 3 blocks, so that's 3 units. And the length of this leg would be 4 blocks. And without knowing what the length of this is, we would be able to find it. So what Pythagorean theorem says is that A squared plus B squared equals C squared. And if you look at the math, it goes like this. 3 squared plus 4 squared, 3 times 3, and 4 times 4 is going to give us how many blocks are behind here. So 9 squared plus 16 equals x squared. 25 is x squared, so that's really the area behind it. And then we take the square root, that's how we undo a square, and x is 5. So if we just wanted to find out the side of that triangle, it's going to be 5. We're going to use Pythagorean theorem to either find either of the legs, A or B, or either of the hypotenuse, C. So what I want you to write down is that Pythagorean theorem is A squared plus B squared equals C squared. And I want you to make arrows that these two are the legs. And I want you to note that this C is always the hypotenuse. Okay? So I want you to note that A and B are the legs, C is the hypotenuse. A and B are interchangeable. It does not matter which leg you put where. So let's look at an example together, and then hopefully you can try the next one on your own. when we come to this triangle, we want to be able to identify if we're missing the leg or we're missing the hypotenuse. So take a quick second. Hopefully you realize that x is the hypotenuse. So if I need to fill out the formula a squared equals b squared equals c squared, then I'm going to fill out 30 squared plus 16 squared equals x squared, since x is our hypotenuse. Continue the math. 900 plus 256 equals x squared. 1156 equals x squared. I then need to take the square root. Please note that this example, and from here on out, whenever we do Pythagorean theorem problems, the answer is always going to be in simple radical form. So I take the square root of 1156, and what is nice is that it is a simple, easy number, 34. There is no decimal. If it was a decimal, we would have to break it down into simple radical form. So go ahead, try this one. Again, let's take note as to what x is, and x is, again, the hypotenuse, so you're going to set it up very similar to this one. So go ahead, take a second, try it on your own. So we should have got 4 squared, 9 squared plus 4 squared. Wouldn't matter in whichever one you put first, 9 or 4, it does not matter. Square them both, so it's 81 plus 16 equals x squared. We're going to get x squared equals 97. We're going to get x equals the square root of 97. If we put that in a calculator, we're going to get 9.85. Well, guess what? We can't get a decimal. So you must break down 97 into a factor tree. Well, there are no factors that really go into 97. So we're going to leave our answer as x is the square root of 97. And if you think about it, I know, or you should know, that the square root of 100 is 10. So if the square root of 100 is 10, this answer is very close to 10. And we want to check, one thing you can always check, you want to make sure that if you're finding the hypotenuse, and the hypotenuse has to be the longest side, that your answer is the longest side. If for some reason you got an answer that is smaller than 30 or 16, then you know you might have done it wrong. Okay, after this, I think we can go kind of fast. If we look at this example, the only difference from this example to the previous example is, what is x? Is x an hypotenuse, or is x the leg? Hopefully you came up with that x is the leg. Since x is the leg, we have to either call it a or b, and it does not matter. So you'll see here, I call it x squared plus 3 squared, because they're both the legs, equals the hypotenuse squared. You have to remember that there's also a squared on the hypotenuse. So when I do my math, I get x squared plus 9 equals 25. So to solve, I subtract 9. I get x squared equals 16. And then, of course, I take the square root, and x is 4. Since it's a leg, it should be shorter than the hypotenuse, in which it is. Go ahead and take a second and try this one on your own for sure. We'll talk about this one in a second because it has a radical. Other than that, it's not hard. But please go ahead and do this one. Take a second. Pause the video. Okay. Hopefully you got 3 squared plus 6 squared is x squared. 9 plus 36. X is the square root of 45. Problem is, you cannot give me a decimal, so you have to break down 45. And when you break down the square root of 45, you could do 9 and 5. 9 breaks down to 3 and 3, so our final answer is 3 root 5. Good job if you got that all by yourself. Let's look at the next one, and the only thing that's funny is that you're going to have to take this 8 the square root of 2. So let's look at this. When we set this up, it's going to be x squared, because it's a leg, plus 8 squared equals. And remember, we're going to have to square both 8 the square root of 2 squared. When we get our next step, it's x squared plus 64 equals. These are two separate numbers, so they're both going to get squared separately. You're going to take 8 squared, which is 64, and we're going to take the square root of 2 squared. Now, you can put it in a calculator, or the square root of 2 times the square root of 2 is the square root of 4. And what is the square root of 4? 2. So this radical comes out to actually be 128. I subtract over, I get x squared equals 64, and the square root of 64 is 8. So you want, even though it looks like it's going to be hard, you please try to remember that you take 8 and you square it, and you take the square root of 2 and you square it, and you multiply it. Squaring a square root is always going to get rid of the square root. All right, go ahead, pause the video, please. Do this problem all by yourself. Okay, hopefully you did try it by yourself. Very simple. X is the hypotenuse, so therefore it's going to be 7 squared plus 24 squared equals x squared, 49, 576. The square root of 674 is our final answer. But is that a decimal? Yes. So I need to break it down. And if you broke it down correctly, it should be 15 the square root of 3. Let's look at an application problem here. It's actually drawn for you, so it should actually be really easy. But just consider in any ladder problem, when the ladder is leaning up against the house, some people tend to think the ladder is going straight up and down. You can't climb a ladder, people, if it's straight up and down. So please recall that the ladder in any ladder against the house problem is going to be the hypotenuse. So where it says a 16-foot ladder rests against the side of the house, please remember the ladder has to stick out a little bit. So that's 16. The base of the ladder, so that's the bottom of the ladder, which would be on the ground, 4 feet away from the house. How high above the ground is the top of the ladder? So go ahead, pause the video, see if you can do this by yourself. Here's the thing, this is an application problem, so it's going to make more sense if we get decimals. So you are allowed to get a decimal. You do not have to put it in simple radical form. Hopefully you did x squared plus 4 squared, because those are your legs. They're the ones making up the right angle, and 16 is the hypotenuse. X squared equals plus 16 equals 256. X squared equals 240. X actually equals the square root of 240. And since it's an application problem, you're allowed to leave it as a decimal. So 15.49 or 15.5, depending on what I tell you to round to. That's basically Pythagorean theorem. We're done. There's nothing else you can really do with Pythagorean theorem. I just want to talk about, they mention this in the textbook. It's called a Pythagorean triple. And all it really is 3 numbers, a set of 3 positive integers that are always going to satisfy the equation a squared plus b squared equals c squared. Meaning that they're never going to give you a decimal. So if you looked at these numbers, for example, 3, 4, 5, if I take 3 squared, it's 9, plus 4 squared is 16. 9 plus 16 is 25. Square root, 5. So it's just going to be 3 numbers that when you put them into a squared plus b squared equals c squared, you don't get a decimal. Same goes for 5, 12, and 13. So 5 squared is 25, 12 squared is 144, 144 plus 25 is 169, the square root's 13. You do not have to memorize these numbers at all. I'm just going to tell you that you're probably going to get pretty familiar with them, because anytime I don't want the answer to be a decimal, I always resort to one of these numbers. The other thing that's nice about these is that if 3, 4, 5 works, any multiple of 3, 4, 5 works. So if I multiply by 2, it will also work.